Hello everyone. So my presentation today is about software security. I will be briefly talking about how it is like working with the software security field, what I do in my everyday job, and what the type of activities we are involved in when we try to build a secure software. So to start, my name is Asma Bni. I am a software security engineer at Axis Communication. I have basically my background is computer science, so I have studied computer science and I was introduced to software security during my master's studies. And to me, it seems like software security is always like an extra mile that you have to do after software development. So to create a secure application that can be safe to use as well as a fun experience for the users using it. So the software security seems challenging and a lot of learning and growing working with security. But that's basically what makes me like it and want to pursue a career in it. And yeah, and basically this is more like a small talk, maybe hopefully to inspire and for you to think about yeah, what the type of activities we do and how is it like to work with software security. So the agenda for this presentation, first we're gonna talk about why software security, why is it so important, and why we see more demands in many companies to have software security engineers on board. And then we're gonna talk about software security lines of defense. For the companies usually that implement software securities, they have a type of model and activities that they are work on in order to have maintain a good quality like secure software. And then the last part is about security testing, and that's mainly is like how to develop your skills and how to find like vulnerabilities in bugs in the software. So yeah, why is software security important? I mean, we hear a lot in the news about many breaches and vulnerabilities that cost a lot of money to companies. So I think now, from now in the future, there is so many requirements for the companies to actually build a very secure software by the customers in the first place, because that's actually it becomes more and more important in relevant, especially that now everything is connected to the internet. So for that, we can start basically, I'll just give a quick introduction about what Axis does. So Axis, in a nutshell, is a company that creates like intelligent and smart solution for safety and security of customers. These devices include like network cameras, network audio devices, that can basically be installed in the customer premises and can be used for like many other things as surveillance, and comes with a bunch of like tools and application which allow the analysis and the access control of the devices. But the other also many new features, these devices can be uh, connected to the internet, to the cloud solution, and basically that means that anyone can be able to watch a video stream uh, from when connected to the internet. So with that in mind, it comes a lot of like risk and challenges by developing these type of security products that are built to ensure security. So that's why it is also it is actually needed to have more high standard and when it comes to security for the customers. And think of that, the customers are worried because, I mean, what can possibly go wrong? There is many threats actually when you have connected small devices to your network or to the internet. So there is a larger surface of attacks that actually can be leveraged against these products or devices. It could be anywhere from staging an attack against the customer's network through our devices. It could be basically accessing video feed. It could be basically a lot of things. And as an example as well, this is like a vulnerability report which was received by the team here at Axis. So it basically was a security researchers. So there is many security researchers also that are very curious about the software, and they are trying to find a way to exploit and manipulate it. So this was an exploit found in one of the products, which affect basically all of the devices. And with this flow, it will basically allow anyone to remotely exploit our devices. And yeah, so basically this also raised more like a warning sign that we really need to work on security when it comes to developing software. And basically here, so for this case, we have like in every company there is always the security team, which plays the role of the defender. So the security team is usually trying to find all the security bugs and have access to all the source code, to everything that the teams are working on, all the design paper, etc. But that means it's a huge responsibility. I think it's very difficult to cover all the security bugs. On the other side, we have the attackers basically, that they don't have as much access to all the information that the security team have, but they only need to find one security vulnerability to basically just one exploitation for them to access the system and do malicious actions. So basically, in order to do this, there is many activities that we work on. So the security team does a lot of like architecture analysis. So this is we trying to hunt or find for security issues already in the design stage of the software development. And then followed up by the code review. And in that case, we try to find vulnerabilities during the implementation phase. So when you're writing code, we basically help in the code review, either by a security analyst or by some tools that also does code analysis. And then we have the latest stage is security test. So basically this after the delivery of the product or the release, when the implementation stage is done. So the security test is done also by the security team, and we try to find security issues in the software that basically could not cover by either of these two activities. So software security lines of defense. Basically here we will talk about how we maintain security in our product. And basically this is not wait until the end and then try to hack the product and find the vulnerabilities. But this work actually starts really early on in the process, and we try to find as much vulnerabilities as possible before we reach to the stage when we have the delivery of the software or our product is finished. So to start, so we have the software development life cycle. So when trying to develop a software, it always goes by the early stages of requirements in design. In that case, we try to identify, okay, what we are trying to build here and what the purpose of this software. And in that case, we do a lot of like activities such as risk assessment and architecture review, and then followed up actually once the design is clear. Then is the implementation phase, when actually you write code to create the software. And for that stage, we do something called a code review that could be done manually or automatically using a tool. Then we have the verification stage, where we do security testing on the final product before actually sending it to the customer. So how we do this architecture analysis? So the architecture analysis is, as we mentioned before, is done during the requirements and design stage of software development. And we do an activity called threat model, and I show here. So before doing that, we actually have to do some sort of like system risk heat map. So we try to identify the components in the application that have high risk, and we do security assessment or threat modeling accordingly. So usually it's cloud applications are very high risk and requires a lot of work to secure. And then we have devices and web or mobile applications, etc. Then basically we have the risk assessment, that after we define like the area which we work on, then we have basically the feature or the product definition, and then the risk assessment will help define if we need to do any security assessment, if not all on the feature. This is basically because security work adds a lot of overload for the team. So it's always good to do a sort of a risk assessment to define what are like basically the benefits of doing security and how much work that the team needs to do in order to have to implement a secure software. So for threat modeling, so now we have basically a feature or a product that we are working on, which we need to do security assessment. So we will need to start with the threat modeling, and basically this will help us more understand the application and the purpose. So start by describing the system, identifying use cases, possible attackers, and then after that, depending on the use cases, we start to find threats and how an attacker will basically try to abuse the use case. And according to that, we define like the verification test that we need to do, or the implementation that we need to do to create countermeasure against these attacks. This is shows like a diagram. It basically shows a use case scenario. So it could be something like a diagram that shows like what's the intent of the application we're building on. So for example, here it's a very simple diagram, shows that it's a small server that a user communicate to through using HTTP request, and we basically try to highlight what the action, what are all the data flows, all the use case that the user have in this feature or product. So once we identified, we also need to identify the premises. That basically shows us where the application is hosted. Is it going to be in the corporate network? Is it going to be in the internet? How it is accessed by the user, but also that help us define the type of attackers that we are trying to secure the software against. And then we have here, we managed to list 3 types of attackers. So we have the internet attacker, or the authenticated user that it has malicious intent. We have the network, someone who is also have same access to the corporate network. And then we have the compromised server. This can be anything from like a malicious program installed on the server, or like a malware basically that do malicious things inside the server. And basically now that we have clear, we know the intent of the feature, the application we're building, we know the attackers that we are trying to secure the software against. So what we are doing is we will try to analyze what type of attacks are possible, or what type of malicious acts we are trying to protect against. And it's a variety of them. So for example, here we're trying to protect against attackers who sniff the network and read the data. We're trying to protect against someone who is trying to change the data before it's reached to the server, or try to stop other users from using the application, etc. So there is so many different abuse scenarios that we really need to think of, and we really need to as well think of how we can protect against. And this is how it comes here, that we basically trying to prioritize what is the threat that has higher risk. So for example, someone who is able to read and manipulate the data, that seems like a very critical risk. If anyone can do that, an attacker can manipulate this, and we lose the integrity of our application. We use also the confidentiality of our application. So we always rate every threat by the severity, and that also gives the team more like a backlog, like what they need to implement urgently, and what the other things that can actually fix when it's suitable. So it's always a good practice to prioritize in rate threat by the severity. And yeah, I think threat modeling is usually by doing that, you create a sort of like a document that is used by the team, where they actually have more guidance on how to implement security in their software. And each document is basically designed depending on the feature or the product that the team working on. So with every new feature, we have to come up with a new threat model for it. And it also gives them an idea what they need to verify afterwards. So the second, after doing architecture review, we go to the second phase, where now that the team knows how they need to secure their software early on. So the next stage will be actually to implement all the security mechanism, and for that they also need to do some sort of code review. I think because it's very important, because it could be a lot of like misunderstanding about how it should be implemented, or it could be an implementation that actually does not protect against the flow, the security flow. So the code review basically is we try to do it to identify vulnerabilities in the code, and it should be done by either there are tools that are built to do this, and or by a security analyst, someone else who read the code, and he can or she can identify security flows in the code. So, and that could be done like locally, could be run on the developer disk. He could actually run a code analysis tool, or it could be actually done when pushing your code to repository, then there should be like automatically a feedback by the tool about possible security issues in the code. Okay, the next part is about security testing. So security testing is trying to act like the bad guy, and trying to find flaws in the application. And for this case, we have the white hat hacker. That's basically the security engineer that's work for security testing. And then we have the black hat, is basically the bad guy, the malicious user that are trying to exploit or find flaws in the application. So it's the same concept. The only thing with the white hat is more like ethical. It's basically your job, what you do. And more for the black hat is more like malicious user, but he wants to gain access somehow to your application, and it's actually not legal. So for security testing in general, it's a procedure to be able to find security flaws in your application. And to do that, we also need to have a lot of tools in place. We have to do it not just once, but we have to do it very often. We have to protect against the security flaw or find the security flaw. So that's why we have three main activities that the security team work on. So we have the automated security testing, and the purpose is to make sure that all the issues that we have, security issues that we have found and fixed, they are still maintained. That means that it checks that everything that we think that works fine is or secure is still secure, that there is nothing broken. So it's a way to actually ensure that we have a good security in our product. And then for the other one, the fast testing, that's more like it's an automatic type of testing, and it's trying to actually hunt for errors and potential security issues in the application. So usually the malicious users tend to use this technique by manipulating the data to try to find ways into your application. And this will actually, doing fast testing will make it really harder for others to find vulnerabilities, because we are already early finding that the type of problems in the way we manage or we process data that could cause problems in the future. And then we have the pen test. Is basically this done by someone who has a lot of experience in scale for security testing. It's a lot of time consuming, but it's something that you basically, your application is assessed or basically tested by someone who have experience doing security testing, and that helps give you an overview assessment of if you have missed on something during the architecture design or during the code review. So the way we work with automated security test, so it actually follows from the other activities. When we do architecture analysis of the application to find potential security flaws early on, and we implement the protection against them. At the same time, we also create a security test plan. Means that we create automated security tests that basically make sure that this feature or code that protects against the flaw is actually working. And follow that by that as well. At the end of the release, when we do also penetration testing, means we try to find flaws in the final stage in the actual application. And if we find any issues, then we use that as a feedback loop, and we feed it again to the security automation. So all the fixed bugs as well needs to be a test case for them needs to be automated in the security automation framework. So for the fast testing here, it's a different technique. Is you have basically your application, and when you basically do code or test or review, you cover not everything in the application, but Fuzzy help you find interesting path in your code that you could not cover before. And the way it works is fuzzing is usually, there are many tools available on the market, or basically open source tools. So most of these tools try to learn more about your application while sending data to it. So it's more about a learning process when it just generates many data and then send it to your application, and then see how the application will react to the data. And that's use something called the monitoring program, which monitors how your application. And the reason is data is usually it's the attackers, even the users, way into your application. So there is a high risk to actually find security problems in the data that feeded by the user to the application. And if it's not properly sanitized, that means that there is many ways to actually abuse your application. So Fuzzer help you try to see like the errors or the possibilities of abusing your software using the data that the users feed into your software. So it's a very important activity, and it's also very valuable to actually see, because this something could easily be missed by all the activities we have done before, like by the architecture analysis or the code review. And then we have the pen test. Maybe many of you heard about it, but for the pen test part, it's usually done by a security analyst, and it's the same. He usually, the security analyst will try to do the same technique and the same thinking as a hacker would do to your application. So it goes through many stages, and it's a lot of like time consuming. So the pen testing basically goes by first trying to learn more about your application the way a hacker does, and try to see how much information is revealed by your application. So that's the first stage. And then the second stage, now that he understands how the application work, and basically what kind of maybe technology stack your application use, what kind of programming language probably you have used to build your application. All these pieces of information are very important for a pen tester or a hacker. And then it comes the second stage, is depending on this information, is try basically to find intelligent way to see what can he actually exploit or how he can manipulate your application based on what he learned on. And after that, then he will go to the vulnerability analysis, basically try to use many like scanners, tools to scan for vulnerabilities, or based on the knowledge he have acquired, try to guess what kind of vulnerabilities it might be possible to find in your application, etc. Then basically the fourth phase, the exploitation. So here basically try to actually demonstrate the security flaw. So it's always like you have, it's not just enough to pinpoint where the problem is, but you have to actually demonstrate how this can be dangerous for your application, and why this is a security vulnerabilities. So the pen tester or the hacker try to show you like the possible impact that this vulnerability have on your application. The post-exploitation basically is as well very important, as many developers build the application, but also build a way to be possible to trace if there was any errors or any traces of anything going wrong in the application. But what happened actually when a hacker attack your application? It's also very important that he cannot hide any traces or delete anything that shows that your application have been compromised. So this is also what goes into the post-exploitation. The hacker or the pen tester will try to hide his traces in the application and see if that succeeded or not. And this is very relevant for applications that are built in the cloud, for example, because it's very important to be able to notice when someone is attacking your server or service. It's important to notice if someone have gained internal access to your application. So these informations are very valuable for the customers, maybe for the developers as well. But at the same time, for the hacker, he does not want to leave any traces when he managed to exploit an application. And then we come to the reporting stage. This basically, it's very important. It's a learning experience for both the pen tester and for the company. So to show like how much he managed to learn about the application, shows during the time how much he managed to exploit, to find exploit or security problem in the application. But for our case, we are an internal security team in Ataxis, and we do a lot of security testing for the goal, of course, to have a secure software at the end. But as well, we do it also to ensure that the amount of work that we have done earlier during the design and implementation stage is actually working, and that our goal at the end is not to find many security vulnerabilities during the testing. Although that we do, but still we need to actually try to catch these problems early on during the development or the implementation in design stage, because it's very costly to fix problems when everything at the end, when you have already like delivered, and then you need to patch the software and many other costs. So it's always very useful to find security problems in the beginning of the process. And just to end this presentation, maybe a small fun part. So it's a small demo about common security vulnerabilities. You see this in many web application, and I think it's a very good example to show. So the vulnerability is called cross-site request forgery attack. And as the name shows, cross-site is crossing between sites. So this attack is possible because of the user using many web applications at the same time on a browser. So when the user opens a browser and opens many websites and many sessions, so usually you should never trust the contents loaded in your web browser. So for example, let's see in this use case that the user here is an admin of a device, or a user of a device management, and he opened the management web application of the device in our case, but at the same time he's checking basically some content on some unknown domain or some other site, but he doesn't know so much what actually loaded or what this application does. But this application is basically served by a malicious attacker that try to actually do changes in the devices, or create users in the devices and exploit in a way. So then we basically, in this case, this shows an example. So for this attack, we did like a small proof of concept or example. So it's just basically an HTML code. It could be also a JavaScript code as well, and this is served in a server, and the user, the victim here, is trying to visit this website, but he doesn't know that there is a hidden frame that will be executed once he actually visits the website. And in this hidden frame, the attacker will try to send a request with the victim, the malicious, the victim credential to create a new user in the device. And let's just see the demo, how it goes. So this is a browser, and let's see, I am the admin. I opened my application in the browser. But then I got this link sent to me by someone, or I just found this on the internet, and I have tried to visit the attacker site, now the malicious site. So what do I see? It's very simple. I get load some funny image, but behind that is actually, we see behind the scene that a request is sent, and the reason why this attack works is because the browser always attach the session, the user credentials to the request for HTML forms, and we see here that it's successfully. So if we go back and we just load, so we see that a user is created in the system, but it's not by the admin, but it's by the attacker script. And this in itself is basically a common web attack. So how we can do to protect against this? So for that reason, we need to build a security measure early on. So when we create our web application, and we think of this attack early on during the implementation or the design phase, we see like how can we then protect against someone trying, if a user loaded script of an attacker try to do changes in the web or the device application. So basically the thing is, we need to there need to be a new information, not just the user session, as a way to make the request happen. And that's what's called token. Is basically a random information that cannot be guessed by the attacker, and it should be added to every request sent to the device. And this basically for the application to ensure that the request comes actually from the right right client application. The other also way possible is to work with requests that have maybe JSON context only and accept only JSON bodies. And the reason why is because most of these attacks rely on the HTML forms, because they do not check the cross-domain between the websites, and also because most of the HTML form until now, they don't support requests that has JSON type of data. And then basically that if uses by JavaScript, then have to check the permission first from the server, and in this case which should not be configured to actually send a reply to requests coming from another domain than the legitimate web server domain. And here, so now we have basically built this application. In this case, we have identified the threat, and we have created a security measure for it. So to see now the difference is basically the admin here is logged into the site and visits the malicious attacker website. And you see the request here is failed. You can see in the debugging console that the request is not sent. And the reason here is basically the HTML form sends text plain, which is not admitted by the application. So here the attacker failed to actually create or another sites in the application. Yes. Okay. But that was it for my presentation. Thank you so much for listening, and I hope to hear from you soon in the questions session. If you have any question or if you're curious about anything for this presentation, and yeah, thank you so much. Goodbye.